Good day, students. You are welcome to the maiden edition of Nelstar Tutorial. This is Nelstar Tutorial. My name is Justin Yumata. My phone number is here. I'm going to teach you the following subjects and courses. The first one there is General Mathematics, O level. General Mathematics is the first step of mathematics you see before you enter into any aspect of calculation. After that, I will also teach you physics O level, chemistry O level, basic programming, additional or further mathematics, computer science, statistics 1, that is introduction to statistics, calculus 1, introduction to calculus. Under maths A level, I will be teaching you pure mathematics, statistics 2, mechanics, calculus 2. Then I will also be teaching you calculus 3. Calculus 3 is more or less university mathematics calculus. Then I will also be teaching you differential equations with boundary value problems. And finally, I will also be teaching you advanced differential equations and special functions. For the first 6 months, I'll be teaching you from 1, General Mathematics O level, to 9D, Calculus 2. After 6 months, I will now enter into Calculus 3, differential equations with special boundary value problems, then advanced differential equations and special functions. These last 2 are more or less meant for those doing master's degree in mathematics. So today, we are going to start with the first one there, General Mathematics O level. General Maths O level. This is the first entrance into mathematics, general mathematics. It lays the foundation for any other topics or any other thing that has to do with mathematics to follow. So a proper understanding of general mathematics marks a proper understanding of all these things that are written here. So you're expected to pay attention. Now, what is mathematics? Does mathematics have a definition? Because in those days, when mathematics was introduced to us, we are not given any definition. Other subjects like chemistry, physics, economics, geography, others, they have their own definition. They give us the definition of what those also. But when it comes to mathematics, no definition was given to us. We were given the impression that mathematics is just solve and get answer. This problem of under normal condition, mathematics is supposed to have a definition. After definition, then different classifications of mathematics. The importance of mathematics. How to study and understand mathematics before you know that thing under mathematics comes. This problem is mainly caused by those in the various ministries of education, the education planners, the curriculum which they want to hand over to teachers. You can't see these things are mentioned. A situation where other subjects like chemistry, physics, biology, history, geography have definitions, but none for mathematics. That is where one of the problems we have with our young ones in studying mathematics starts. A situation where told gave impression that mathematics is solve and get answer. No. So we will begin mathematics with definition. So we define mathematics as follows. Mathematics is a method of thinking and studying the pattern, relationship of quantities, physical and non-physical, using numbers and symbols, as well as the study of the pattern of shapes. Now, how did mathematics come about? Was it given to us by nature, or mathematics is it man-made? We came into this world to meet languages. Some languages like English language, French language, German language, Russian language, Spanish language, and a lot of thousands of other languages. We came into this world to meet them. And we wanted to rely on these languages, to use these languages to study our environment. to know things around us. But our reliance on these languages could not take us far. We were having some problems in terms of communication between A and B, between Mr. A and Mr. B, communication between one country and another, communication between individual and individual, between individual and companies. Hence, human beings started looking for a way to have perfect communication. Hence, human beings started developing mathematics. So mathematics is man-made. It is not naturally given to us. As we have language, English language, French language, and all those other languages that was given to us by nature. Mathematics was not given to us by nature. Mathematics was developed by man in order to solve and understand his environment. Now, different empires have at one time or another ruled the world. The Babylonian Empire, the Roman Empire, the Mughal Empire, and whatnot. And each point of time, these people made some contribution to the development of mathematics. Because in those days, when people were predominantly farmers, if a farmer takes 5 cows or 5 sheep into the bush to go and feed, the farmer will collect 5 stones. Collect 5 stones from outside and go and keep that 5 stones inside the house, signifying the 5 cows or 5 sheep that are taken to the farm to go and feed. When the sheep or the cow come back in the evening, the farmer will go and collect those 5 stones or pebbles kept inside the house, collect them from inside the house and throw them away. These are some of the problems of people who are trying to devise a way of mathematics. When you go to some of these old fathers during the ancient time, if you go to their bed or their roof of the house or the door of their, they make certain marks on wood, something like marks like this. They carved wood, they make something like this. Some of this signifies somebody who has taken something from them. It may be money, it may be one gift, one thing or the other they gave the person. So to enable them not to forget, they go and make some marks. These were crude ways human beings were using that time to devise a perfect way of communication. Now look at this statement. This instruction was given to the madam of the house, to his housemate, to her housemate. The madam of the house gave my housemate this instruction to execute. See, I am hosting the meeting of our club. I am expecting a reasonable number of people. So cook some quantity of rice. Hire some appreciable number of chairs. And fry some sizable quantity of meat. This instruction the madam of the house gave to the housemate. They never have prepared for the people that are coming. The people that are coming. The question you ask yourself now is this: what is reasonable in the eye of the madam may not be reasonable in the eye of the housemaid. Cook some quantity of rice. What do you mean by some quantity of rice? What is some to the madam may not be some to the housemaid. Hire some appreciable number of chairs. The same confusion continues. And then fry some sizable quantity of meat. What do you mean by sizable? What is sizable in the eye of the madam may not be sizable in the eye of the housemaid. You can see how imperfect this type of communication is. There are bound to be misunderstanding with this type of communication. There are bound to be quarrel between the madam and the housemaid. But assuming the madam of the house has put this instruction in this way: I am hosting the meeting of our club. I am expecting 200 guests. So cook 35 cups of rice. Hire 210 chairs and fry 12 kilograms of meat and so on. You can see that this second instruction is clear, more perfect, straightforward, not subject to misunderstanding. Provided one condition is met. What is the condition? 1. That all over the world, we have agreed on what 1 cup is. That is, what is the size of 1 cup? 2, what is, no, 2, how big is 1 kilogram? 3, numbers, this I mentioned 200, I mentioned here 210. So a type of number system like 1, 2, 3 continues up to 200, 210 and continues non-stop up to million and trillion. This thing can only have meaning if we have agreed on all these things worldwide, not only between the madam and the housemaid. So that when you tell the housemaid the number of cups of rice is going to cook, since she knows the size of 1 cup, she will now use this cup and measure 35 cups. This problem has been solved. How big is 1 kilogram of meat? If you know how big 1 kilogram of meat is, then you can now measure 12 kilograms and fry. This problem has been solved. We measure something like 200 guests, 210 chairs. Now, we have a number system that begins with maybe 1, 2, 3, continues up to that 200, continue to that 210, continue up to 1 million or 1 trillion. Quantification. Now you know that this one, 2 is bigger than this 1, 3 is bigger than 2, 200 is bigger than 300, is 3, 210 is bigger than 200 and bigger than 210, and so on. You get to million, get to 1 billion, and so on. This was the problem mankind were having. And the search to solve this problem of man, because of imperfect communication between individuals and individuals, continues. Various empires will come, they use their own method. The Roman Empire had their own. Germans, the Babylonians had their own, and so on. But it came to a time, Aristotle brought out a one that was acceptable to most part of the world. Galileo Galilei wrote this thing. This number system, 2, 3, non-stop, to 1,000, to million, to billion, to trillion. It's continuous non-stop. He called this natural, or call it counting numbers. You use a big N to represent it. This was introduced by Galileo Galilei. When it was introduced, as usual, most parts of the world did not accept it. Some were using it. It took many years, thousands of years, before it became generally accepted. And now people were having something to rely on in order to communicate those things that are quantifiable. So the world were happy, they were using it. As time continued, it was discovered that these counting numbers could not solve certain problems which man had. For instance, not this natural number. For instance, with this natural number now, certain things cannot be communicated between them. For instance, 1 is here, 2 is here, 3 here, 4 here, continuous. Let me take a number like 25. This data means it's continuous. So 25 is among here. This 25 now can serve us of various purposes, depending on what you want to relate it to. For instance, 1, there are 25 students in the class. 2, I need 25 cups of rice. 3, I need $25 for the weight of that thing you're holding is 25 Newton weight. 5, in terms of gender, there are 25 boys, or there are also 25 girls. 6, the distance from one location to another is 25 meters or 25 kilometers, etc., etc. Depending on what you are looking for, what you want to relate this 25 to. This 25, you can see the various purposes in serving us. Then you put the appropriate units to indicate what you mean. Here it's talking about number of people, students. Here it's talking about cost of rice. Here it's talking about currency. Here it's talking about weight. 25 boys, 25 girls. Talking about gender. It's talking about distance. So any number you pick from this counting or natural number can be used to serve a purpose like this. This lesson I'm teaching you now may take up to 25 to 30 minutes. All these are the world we are happy with what Galileo Galilei introduced to the world. And the world we are using it, they were happy. But along the line, mankind discovered that what Galileo gave them could not take care of certain problems they were having. Hence, mankind worked on this and improved on it. And added another thing called 0, 1, 2, 3. This continues. When 0 was added, the number changed from natural or counting numbers to whole numbers. With the symbol W. With this now, this one is better than this. It's more complete than this because 0 came to serve a lot of purpose. For instance, is there anybody in the farm? Is there anybody in the house? There's nobody. 0. My account is there's no money at all in my account. There's no money about in my account. That is dollar equivalent. 0. Does anybody look for me today? Nobody. 0. And so on and so forth. That was how 0 entered the number system. And the number changed from natural numbers to whole numbers. The symbol is big W. So life progressed. It has always been a problem. Whenever you change from one number system to another number system, there must always be resistance. When this one came out, some people accepted it. It took thousands of years again before these whole numbers were accepted. Now, as the world continued to use this number system called whole numbers, later on, they found out that these whole numbers could not solve such things they are coming across in life. Mankind now improved on these whole numbers to get something like this. Non-stop. Continues non-stop. When this thing was introduced, changed from this to this was given another name called integers. Symbol, capital I. Now, this integers was a better improvement to whole numbers. Certain problems this one could not take care of. This integers are taking care of it. For instance, credit me with $100. My account I have in the bank. I have anywhere. You add $100 to it. I have been credited with $100. Debit me with $100. Account I have in the bank. Minus $100 from it. You can see it. Every number here has a corresponding opposite. This is 3 plus 3. This is minus 3. This is plus 2. This is minus 2. This plus 1, this minus 1. 0 is at the center. It's neither here or there. You can see a simple application of certain problems when they are coming. You can credit somebody with $100. You can debit. This is credit. CR. Credit somebody. Debit. DR. Now, some parts of this world, or certain things, when you put certain things in the fridge, temperature of something, may rise 1 degree centigrade, 5 degrees centigrade, 30 degrees centigrade, and so on. But there are situations where temperature falls below 0 degrees centigrade. You get minus 2 degrees centigrade, minus 5 degrees centigrade, minus 10 degrees centigrade. The temperature of certain places in this world, in this world, is in negative form. Also, some other application of these negative numbers. This is the level land. During rainy season, the land gets flooded. You can see water level rises. You can see from here to here. Water is now 2 cm, has risen above the normal level. But during droughts, when the rain start going inside the ground, this now from here to here now, the rain has fallen to what? Minus 1 cm. It has fallen down, minus 2 cm, and so on. So various problems like this which you come across in nature relate to the introduction of these negative numbers. So with this this number system called the integers, the number system at our disposal now became richer. So the world continues. And these integers was also accepted, not immediately, but with reluctance. But it took a number of thousands of years before this number system called integers became generally accepted. Now, as time progressed, human beings discovered that these integers can be improved upon. What did they discover? They discovered that in between any two integers, in between any space, any integer, there are 1,001 numbers that lie in between them. This is how fractions enter into mathematics. Between 1 and 2, between 0 and 1. For instance, between 0 and 1, 0 plus 1 divided by 2, it gives you 1 over 2 equals 0.5. A lot of numbers lie in between 0 and 1. A lot of numbers lie in between 1 and 2. A lot of numbers, thousands, lie in between 2 and 3. So they discovered that these integers, any number on this integer, this number system called integer, can be written like this: A over B. 1 up, 1 down. Any number here can be written like this: A over B. 1 up, 1 down. This is how fraction enter into mathematics. For instance, this ones we wrote here now can be written like this: minus 3, minus 2, minus 1, 0, 1, 2, 3. All these things can be written 1 upon 3 is the same thing as this. 2 is the same thing as this. Everything here can be written 1 up, 1 down. In addition to that, any other number in between two numbers, like e.g. 2 plus 3 divided by 2 equals 5 over 2, which is equal to 2.5. In between here lies this number called 5 over 2. Not only this 5 over 2, a lot of other numbers lies in between these 2 and 3. A lot of numbers lie in between this and this. For instance, this in between here, half is here, 1/4 is here, in between here, 1 over 8 is here, and so on. Hence, mathematicians summarize it as follows: Any number that can be written 1 up and 1 down is called a rational number. And the symbol is big Q. It's called a rational number. Then, also, there are also another number in between 0 and 1. 1 and 2 is another type of number called, it can also be written in the form of this over this. It's called irrational number. Symbol, big I, small r. Now, what is the difference between rational and irrational numbers? That's what we have to look at now. What is the difference between rational and irrational numbers? One. Rational numbers. One thing about rational numbers is this. Since the number can be written 1 up, 1 down, when you divide this thing, it will come to a stop. That is rational numbers. But there are certain numbers, when you divide them, they can never come to a stop. So those numbers written 1 up, 1 down, when you divide them, they come to a stop. They are all called rational numbers. So an example of rational numbers are this. Like this 2 over 1 is equal to 2. 3 over 2, 1.5. 4 up, 5 down, 0.8. And so on and so forth. Once you write one number up, one number down, when you divide it, it comes to a stop. It's called a rational number. But those numbers that you write 1 up, 1 down, but when you divide them, they cannot come to a stop continuously, forever and ever. They are called irrational numbers. For instance, divide this thing and see how it's going to give you. 2 over 7. Examples. 2 over 7. If you divide it, this is what you get. 0.28571 non-stop. Divide the number again like 5 over 13. Divide it. You can never stop. Numbers like root 3. Non-stop. Square root of root 3 gives 1.732 non-stop. 5 over 13. 5 over 13. Root 7. And so on and so forth. So those numbers that when you divide them, they'll come to a stop. Those numbers written in the form of 1 up, 1 down, fraction. When you divide them, they'll peacefully come to a stop. Are called rational numbers. But those numbers in the form of 1 up, 1 down, when you divide them, they will never come to a stop. Those numbers are called irrational numbers. One thing about it is that in between any two integers, there are thousands and millions of both rational and irrational numbers. In between 2 and 3, millions of rational and irrational numbers are here. In between 0 and 1, the same thing. In between -2 and -1, the same thing. This is how we got these numbers, this thing called the rational and irrational numbers. So, in summary, before we summarize, I just discover E, F. This rational plus its counterpart, irrational, is given the name real numbers. This is the biggest housing of numbers mankind had for millions of years. Any number I want to use, anything you're going to do, and you're looking for a number that will qualify you, it was come from this big bowel called the real numbers. And it was serving the purpose of serving the various purposes of mankind for millions of years. Until it got to a time, they discovered that there's another group of numbers higher than this. These numbers are called complex numbers. We will come to the study of complex imaginary and complex numbers. This is the number system. It's the biggest bowel. Any other number talking about real numbers, every other thing is inside here. But at this level of mathematics now, we are not going to introduce it. It's beyond the scope of this general mathematics. We will introduce it when we come to additional or further mathematics, or when we talk about pure mathematics under A level. But for now, this is the biggest housing of whatever thing we are doing now, which is the real number system. So let us see how let us summarize. In summary, we started with the natural numbers n. 1, 2, 3. So when human being improved on this by adding 0, the name changed to what? Whole numbers. Human being continued to use the whole numbers. It came to a time they discovered that they were having certain problems which these whole numbers cannot help them solve. So improvement was made on the whole number system. Now we get the what? Integers. Now along the line, human beings continued to use these integers. The integers was big enough. But it came to a time they discovered that certain things they come across, like fraction, want to share land, a portion of land. The first one will take half of it. The last one, the other one will take 1/4. The other one will take 1/8. These are fractions. That's what how fractions enter into mathematics. Now they say that any integer can be written in this way: 1 up, 1 down. Hence, that brought us into what? Rational. And finally, irrational numbers. Irrational, I told you the difference between this and this. When two numbers are written in this form, A and B, and when you divide one, it comes to a stop. Quietly. This is rational. But if you divide it, refuses to come to a stop, continues going non-stop, it's irrational. The combination of these rational and irrational numbers is now giving the name what? Real numbers. Now for a better understanding of these rational and irrational numbers, of these real numbers, to view it like a picture, pictorially. Now human beings discover that this thing F, E, F, G, these real numbers can be represented on a number line. Here is 0, center. Towards the right, positive numbers. 2, 3, non-stop. This arrow means it doesn't end, forever and ever. This way, -1, -2, -3. Continuously non-stop. This is called the number or real, real line. All these things we are talking about, whether counting number, whether whole number, whether integer, whether rational or whether irrational number, whether irrational number, all of them are here. You give the name number line or real line. This is the first stage. How mathematics started. Before Galileo brought out this, it was very, very crude. Different empires were using different type of methods. But when Galileo brought this, it was gradually that whole world accepted it. And this is the tool we are using today. Until later on, the complex of imaginary numbers came into existence. But for this level of what I'm studying today, we are going to start with the number of the real line. So by next lesson, this is the end of the lesson for today. By next lesson, we are going to look at the various classifications or divisions of mathematics. We also look at the importance of mathematics to mankind. Now we look at how to study and understand mathematics. Thank you for now.